Hi guys, and welcome to Preliminary Chemistry, the Chemical Earth. In this video, we're going to look at the nomenclature of inorganic salts. So we've already started to have a little bit of a look at how we name different compounds, and you will already find another video that focuses on the carbon compounds. But in this one, we're going to look specifically today at how we name some of the inorganic salts, the ionic compounds that we form in the laboratory. So when we're naming inorganic salts, effectively what we have is a compound formed between a cation and an anion. The cations are the positively charged ions, and they're formed by the loss of one or more electrons. And we've started to talk about this in another video when we were looking at ionic bonding. The important thing about cations is they are the ones that are named first, and they keep their full name. So the first part of a compound that contains sodium or potassium or hydrogen or calcium gets named on the basis of that ion first. So where we have a sodium compound, sodium retains its full name. As far as the anions are concerned, the anions are the negative ions, and these have been formed by the gaining of one or more electrons. When we're talking about inorganic salts, the anion is the second part of the name. And the name will actually change depending on the composition. So if it's a single element, a lone element, then we change the ending from an INE to an IDE. And that's common for things like fluorine, chlorine, iodine. They become chlorides, fluorides, iodides, bromides, those sorts of things. So a sodium with a chlorine becomes sodium chloride. Now we also have a few more complex salts that we need to look at, and those are the ones where the element is in combination with oxygen and/or other elements as well. So something like sulfur would be a sulfide unless it's in combination with oxygen. If it's in combination with oxygen, then it becomes a sulfate. And sulfate is one of the important polyatomic ions that we need to have a look at. The SO4 anion has a 2- charge. There's another combination of sulfur and oxygen, SO3. This also has a 2- charge, but as it has one less oxygen, we call it sulfite rather than sulfate. At this point in your chemistry career, it's probably important to focus just on the most common types of these sorts of polyatomic ions at this stage, rather than trying to remember how to name all the variations. So here are a few important examples. The first one is the hydroxide ion, the OH- ion. This is a combination of hydrogen and oxygen, where there is an overall net charge of 1-. The second one is the nitrate ion, the NO3. It too has a 1- charge. The carbonate ion is made of 1 carbon and 3 oxygens, and it has a 2- charge. The phosphate ion is a PO4 with a 3- charge, and it's made up of 1 phosphorus and 4 oxygen atoms. The ammonium ion is one of the few exceptions to this rule in that ammonium actually has a positive charge. It's a 1+ ion, so it's a cation. The sulfate ion we talked about in the previous slide, SO4 2-, and then hydrogen carbonate. This is sometimes also known as the bicarbonate ion for reasons that we don't need to worry about at the moment, but are to do with the presence of the hydrogen there. And this is HCO3-. It's a 1- ion, and the sulfate ion is a 2- ion. There's no real shortcut way to remember each of these ions, so they should be in a table somewhere, handy for you as you're naming different compounds, just until you get used to each of these different combinations and the charge on each one. So here is a question. Do you think you can name all of these different compounds? Well, the first one is sodium as a cation, which keeps its name, and fluorine, which because it's on its own will change to fluoride. So the first one is sodium fluoride. The next one, the cation, is magnesium, and the anion is oxygen. Doesn't quite fit the INE ending, but because it's on its own, it will change to an ide. So this is magnesium oxide. The third one is a combination of aluminium. In this case, aluminium is the cation, and the anion is sulfur. And because it's an anion, it has to change its name from sulfur to sulfide. The fourth one on this list is copper, which is the cation. The anion is SO4, and SO4 is the sulfate. So it's sulfur, but because of the presence of oxygen, the name changes to sulfate. So this compound is copper sulfate. And the last one, the cation is calcium, and it retains its full name, and the end name is bromine. That's the anion, but it changes its name to bromide. So the compound is called calcium bromide. How did you go?